Hi everyone, this is Professor Ross, and I'm here to talk to you about relationships between two variables, and especially how we use scatter plots to interpret these relationships. Let's not forget some of our basic statistical practices that are important for us to always keep in mind. We always want to begin with an understanding of the background of whatever it is we're looking at, and to begin visually, and that's important, so that's part of why we're going to talk about scatter plots first. And then we're going to add numerical summaries after that. Within our scatter plots, we're going to want to look for trends and also deviations in the data. And one of the ones I've highlighted here is that when we start to think about two variables, let's not forget that we want to begin by looking closely at each variable individually, and then to go on to study the relationships between the variables. And that's always good practice, to have an understanding of each of the variables individually. Since we want to attend to especially some of the features of scatter plots today, we won't always go in depth on each variable individually, but that's important practice to do whenever you're studying new data. What kinds of relationships can we have between two variables? Here's a couple of examples we've already looked at so far this year. For example, at the very beginning of the year, we looked at Maryville College freshman ACT scores, and we also looked a little bit at the end of the year GPAs and how things turned out at the end of their freshman year. And we talked a little bit that very first day about how might we try to understand the relationship between those two things. Also in lab number 1, you looked at carbon emissions and the annual temperature at the South Pole. See if you can come up on your own with a pair of variables for a potential relationship. Just pause the video for a second, see if you can come up with your own variables that might have some kind of relationship. Now, when we think about the two variables, ACTs and GPAs, carbon emissions and annual temp, your own two that you thought of, there's potentially different kinds of relationships that there could be between the two variables, but one of the most common ones, and one of the ones that we'll focus on, is an explanatory response relationship. Sometimes you'll hear this talked about as an independent variable and a dependent variable. What is this relationship about? Well, there's a good quote from the book that can help us think about this. A response variable measures an outcome of the study, whereas an explanatory variable explains or causes the changes that we're seeing in the response variable. So how about the examples that we've talked about? For example, ACT scores could be an explanatory variable for the end of the freshman year GPA. We think that somehow their ACT scores are explaining the differences that we're seeing in the GPA. Or carbon emissions could be an explanatory variable for the temperature. So we think that the carbon dioxide in the air is trapping the heat and causing changes in the temperature, and that certainly seems like a possible response explanatory situation. Can you think about the two variables you came up with? Which one would you think of as explanatory and which one as response, if you think that's a possible relationship? Let's move on to see how we like to study this explanatory response relationship. And just before we do, real quick, not all two variables will necessarily be in this relationship. There are certainly other relationships that are possible between two variables, including no relationship at all. So just keep that in mind. However, this is going to be the most common type of relationship we take a look at between variables. The most basic way to study these, and the initial way too, is you want to start visually. So creating a scatter plot is a great way to start looking at the difference between, or the connection between, explanatory and response variables. And you've probably all seen and made scatter plots before. Each point in a scatter plot represents two pieces of data for an individual, one value of the explanatory value and one of the response variable. And so we plot the explanatory variable along the x-axis and the response variable along the y-axis, and that's just common practice among statistics. So whenever you look at a scatter plot, you can assume that whatever is put along the x-axis is the explanatory, the independent variable. Whatever you see along the y-axis is the response variable. And so one person, their explanatory score would be here along the x-axis, and their response variable would be here. An example of scatter plot blood alcohol as a function of a number of beers. Someone did a study where they asked individuals to drink a different number of beers, and then they measured their blood alcohol level, and here's a scatter plot of it. And not too surprising, we can see some really nice things from the scatter plot right away. It's why they're such a valuable tool. We can see for the explanatory variable, the number of beers they drank. We think that's going to explain the differences we see in the blood alcohol level. And so we can see that more beers is tending to go with higher blood alcohol levels. And we see a pretty clear upward trend. Not too surprising, we think that the number of beers should explain why their blood alcohol level is different. How do we interpret a scatter plot? We don't want to just look at it and say, oh wow, that's nice. There are some very specific things we'd like to do when we interpret scatter plots. And the first thing we need to do is to ask ourselves, what form is the data taking in the scatter plot? And we have some very common forms. The most common that we're going to take a look at in this course are linear forms. And so when we see the data falling in some kind of rough line, we believe that that's a linear form, even if it's not all on a perfect line, linear form. Otherwise, maybe the data falls in a curve, so something that's not a straight line but follows a curved path. Or maybe we've got clusters of data, clumps that fall together, or possibly we have no relationship where data is scattered all about. Those form the main types of categories, and once again, linear is going to be the most common one that we take a look at and pay attention to in this course. Once we understand what the form is, then we can talk about several other features. We can't talk about these things without referring back to the form. So it's very important that number one, you think about what the form is. Then number two, you can look at the direction. The direction of the data can be positive if it's going uphill from left to right. So if it starts in the lower left and goes up towards the upper right, as long as lower response goes with lower response and lower explanatory go together, high explanatory, high response go together, that's called positive direction. A negative direction is the opposite, when it starts in the upper left and goes down to the lower right. And no direction means it's not doing either of those things. You'll notice that positive goes from lower left to upper right, negative from upper left to lower right in a straight line. So these two go with a linear form. If you have any other form, curved form, clusters, no relationship, then we say the graph has no direction. We can also take a look at strength, and the strength is simply how close the points lie to the form that you've decided it has. So if you think it looks like a linear form, how close do the points lie to that line? If you think it's a curved form, how close do they lie to the curve? If it's clusters, how tightly clustered are they? So the strength tells us how close they lie to the form that you've selected. So once again, it's important to have that form in mind first. And then outliers and other deviations, those are points that fall far away from the form. So once again, it's important to have a sense of how what form you're looking at, so that you know whether you have outliers that are far from the form. Let's take a look at some different forms. Here's an example of linear forms. Here's one that's got a negative direction to it. Here's one that's got a positive direction. You can see that neither of these is a perfectly straight line of data. That would be very, very rare. Instead, the data kind of falls in a little bit of a cloud, but we can clearly see a line that could go through this and be a good representation of where the data is going. A lot of times, if you think, if I can draw an ellipse around the data, that ellipse gives me a sense of the line. In contrast, here's some nonlinear or curved relationships. I could not draw a straight line that would do the best job of going through this data. And once again here, I can't draw a straight line that does the best job of going through this data. Instead, curves do the best job for that form. Up here we've got clusters of data. You can see a clump of data over here and a clump over here. And so that's an example of when we see these clumps of data falling together, we think about them as clusters, and potentially there's something different between this cluster over here and this one over here. And then no relationship is data scattered all about. So it's important first when you look at a scatter plot to make a judgment. Do I see something linear, curved, clustered, or no relationship? Once we have an understanding of that, we can think about the strength of an association. So in the on the left side here, we have a weaker strength as in contrast to the right where we have stronger. Why? Well, my first judgment comes in the form. What kind of form do these data tend to take? They both look like a linear form. We could draw an ellipse around most of this data here, maybe with an outlier. We could draw a very tight ellipse, almost close to a straight line through this. And that's why this is so much stronger. My ellipse that I draw around it would be so much thinner. Everything is very close to a straight line through this. Whereas here I'd have to have a much fatter ellipse. Even though it's pretty clear a straight line could go through it, it's a lot wider. And so we see this as a weak relationship. What's the relationship? Median household income, the person with the middle household income in a house, is not that closely related to per capita income, so the average income per person in the States. On the other hand, a very strong relationship here, a very close relationship between the number of days where we would need to heat a house and related to the amount of gas, natural gas consumed per day. So of course, we're going to use more gas if we have more days where we need to heat a house. And so we see a difference between a weak and a strong relationship. So we've talked about form and strength. How about outliers? Once again, we should look at the form first. Let's describe in words what this shows. This shows a relationship between IQ scores and GPAs. And it looks like a roughly linear form, although it is somewhat weaker because we've got some scatter here. But a positive direction going uphill here. And we clearly have some things going on that are not following the rest of the trend. For example, here's someone with a relatively high IQ score compared to their GPA, very low GPA for a moderate IQ score. So, of course, we're interested what's going on with this person. Why do they have such a low GPA when they have a decent IQ score? Why aren't they like the rest of the people with this IQ score? Or the same thing here. Here's someone with a very low IQ score but a relatively good GPA. What's going on here? Why are they different than the trend? That's an important question that we want to pursue when we study statistics, is what's going on with the deviations, with the outliers that are not like the rest of the trend. And so that's something you would want to contact these individuals and try and find out what's going on. Why is this person being so successful in some sense? Why is this person struggling so much? In summary, a possible relationship between our variables is going to be explanatory and response relationship. You always want to study each variable first. That's an important part of looking at statistics. We didn't do that much today, but when you do that, for example, in your project, you'll want to analyze each variable first carefully. We're always going to use scatter plots for an initial examination of both variables. It helps us see a lot of things and important things like the form of the relationship, the direction, the strength of the relationship, and also outliers pop out pretty clearly for us on scatter plots. So those are the main things you should know and understand about scatter plots as you study two variables.